Welcome. We are going to talk about solving rational equations. I'm very excited because rational functions are one of my absolute favorites since it ties in factoring and all different polynomials, all different things that we have talked about in Algebra 2 and pre-calc. So let's get started. What the heck is this rational equation that I'm talking about? So a um, a rational equation is going to be an equation that contains at least one rational expression. So, of course, they can include more, but they don't have to. All right, so here, what are we going to do with these things? Well, the first thing is we want to get rid of those pesky fractions. So we are going to clear the fractions by multiplying the LCD, the least common denominator. So I'll teach you how to find the LCD for each of our equations we're going to solve today. But that is going to be the least common denominator, just like dealing with numerical fractions, but now they're just a little bit spicier because we have the polynomials in there. Then we're going to simplify the expression on each side of the equation. We're going to use, like always, inverse operations to isolate our variable, just like we have always done with polynomials. And we're going to check our solutions. Beware of those pesky extraneous solutions, right? Where it looks like it could be a solution, but when we plug it back in, it doesn't work, right? That's going to happen with things like holes and vertical asymptotes, all that good stuff. All right, so we're going to start off not so bad. This isn't a type of equation you may have solved with cross multiplication back in the day. You might have written it like this and then cross multiplying, something like that. Why that works, essentially what we're doing is we're just clearing this fraction by multiplying by our least common denominator. In this case, that's just the variable x, right? If I multiply by x on the left-hand side, that's going to cancel. And I'll have 3 is equal to 15x. All right, well now, got to divide both sides by 15, and we'll get x is equal to a fifth. Now, before I box up my answer, right, I've got to check my work. And so we got 3 over, nice double stack fraction, 1/5. We're trying to figure out, is that equal to 15? All right, well, have no fear. Divided by that fraction, same thing as multiplying by its reciprocal. And of course, we know that 3 times 5 is 15. So we know it worked out. And that is our solution. All right, stepping it up a little bit here. We've got x plus 4, right? This guy is a binomial now, not a monomial, but still, because it's just the one fraction, we'll just multiply by its denominator to clear the fraction. So we've got 14 is equal to 2 times x plus 4. And we could divide both sides by 2. That totally works here, but I feel that students often their first instinct is to go ahead and distribute, so that's totally fine too. So we got 2x plus 8. We're gonna get rid of 8 on both sides. We'll have 6 is equal to 2x. Divide both sides by 2, and we've got x's 3. If I'm too excited, going a little bit too fast, the great thing about YouTube, right? You can speed up or slow down the video. So pause at any time, whatever floats your boat. All right, gotta check our work though. I got a little bit, a little bit cocky, and I boxed my answer already before checking my work. So 14 over 3 plus 4. We're trying to see if that's going to be equal to 2. All right, 14 over 7. And of course, we know that is 2. The great thing about checking our work with problems like these as well is not only do we know, hey, we didn't have any extraneous solutions, our solutions worked, but also it really solidifies, right, the connection between that reverse order of operations and the normal order of operations when we are evaluating rather than solving an equation. And you can see how all the work we've done on the left-hand side kind of is um, the reverse of how we go about checking our work on the right-hand side. So cool. All right. All right, a little bit spicier here, but not crazy, right? We've just been stepping it up a little bit by little bit. First thing I'm going to do, I see that x squared minus 4, and I'm like, oh, I know that is a difference of squares. So let's factor. All right, so we've got 1 over x minus 2 times x plus 2. All right, and then that is equal to 2 over x plus 2. All right, so here I'm going to multiply by that least common denominator. Notice how this x plus 2, right, the denominator over here is contained in this denominator, right? So if I multiply that whole, both sides of the equation by that whole denominator on the left-hand side, it's going to cancel our denominator on the right-hand side as well, kind of like a little 2-for-1 special. So didn't leave myself much space. I'm gonna move my notes over. Don't you wish when you were working in pencil or a pen that you could just move your notes as well too when you run out of space? No, it always makes my students a little jealous. All right, so there's multiplying by the denominator on the left, multiplying by the denominator on the right. So of course we've got pshoo pshoo. It's gonna cancel fully on the left-hand side, and we'll be left with 1. But on the right-hand side, right, only this second binomial will cancel, and we'll still have 2 times x minus 2 here. All right. So again, we could divide by 2, but like I said, most of the time I find students who just can't undo that instinct to distribute. So we're going to do that. We're going to add 4 to both sides. We've got 5 equals 2x. And so right now space, but that is going to be 5 halves. Now, of course, you can write it as 2.5 if you'd like, but there you am, box my answer before you even know it's correct. I like 5 halves because I think that who needs proper fractions anyways? All right, so that was a little messy, so I'm just gonna write it a little bit cleaner. All right, there you go. Now let's check our work. So I've got 1 over 5 halves squared minus 4. And I'm trying to see, is that going to be equal to 2 over 5 halves? See, got to plug that in everywhere. There was an x in our original equation. Notice I went all the way back to the beginning before I had even factored. All right, well, if you're like, that is atrocious, I don't want to deal with that by hand, and you want to check in your calculator, guys, that's totally fine too. So I ended up with, I think, 0.44. Let's go to 0.44, which works. So no shame in my calculator game. There we go. All right, next. Woo. All right, we've got 3 fractions now, but that's okay, right? We have been building up to this point. Nothing scary to see here. First thing I'm going to do is factor, right? Because my hope is that I'm going to end up with a factor of x plus 3 hidden in this trinomial somewhere so that my life gets a little bit easier when I go to clear this fraction. So I'm going to rewrite this as 2 x plus 3 minus 3x over, this is going to factors x plus 3 quantity squared. It's a perfect square trinomial. And then that is equal to 1 over x plus 3. So great news. X plus 3 squared is going to be our least common denominator. So again, did not leave myself enough space. When am I ever going to learn? Ooh, but I don't want to include the highlight and move that. There we go. All right, so thing to remember, right, is because there's subtraction here, when I multiply this side by x plus 3 squared, it's going to get distributed to both of those fractions, okay? All right, so let's see what happens here. Well, one of these factors of x plus 3 squared is going to cancel with the x plus 3 in the denominator here. But I'm going to still have a factor of x plus 3 that I'm multiplying by. Both of them will cancel with the denominator under 3x, though. So then I'll just have minus 3x. And that's going to be equal to, again, only one of those factors is going to cancel on the right-hand side. So I'll have 1 times x plus 3, which is just x plus 3. All right, well, remember up here when I said we were going to clear the fraction, right? Next thing, we haven't had to do a whole lot of this. So we need to simplify the expression, right, before we can start using our inverse operations. So I'm going to have to distribute here. I'm going to have some like terms to combine with that 3x, right? So I'm going to put 2x plus 6 minus 3x equal to x plus 3. All right, well, that's going to be negative x plus 6 is equal to x plus 3. Now watch out here. A common misconception, and students will say, oh, well, these are going to cancel because one's positive and one's negative, but they are on opposite sides of the equation. So what actually happens is I'm going to subtract x from both sides here, and whoop, ran out of space, so I'm going to move up here. I'm going to have negative 2x's plus x equals 3x. What did I say 3x? I meant negative, or positive 3. Oh dear. Alright, so we got negative 2x. I'm going to subtract 6 from both sides. That's negative 3. Divide both sides by negative 2. Get x is equal to 3 halves. Now this is where I would highly recommend checking in your calculator, right? Because otherwise it's going to get kind of gnarly, right? When you think about how you would have to take this 3 halves here, and you'd have to plug it in here, and here, and here, and here, and here, right? That's just, bleh. So plug in your calculator. Why not? Who's got the time to sit around and do that by hand? And guess what? I wouldn't leave you hanging. It works. So we know 3 halves is our answer. All right. Go ahead and do, I know, it's a little bit scary. Do this last example by yourself. Pause the video, try it out, see how you do, and then come back and check it with me. Are you really pausing? Did you really pause the video? I see you. No, you didn't really pause the video and try it yourself. All right, welcome back. So let's go ahead and check how we did on example 5 here. So this is kind of a carbon copy of that last problem we did. Right, just a different for polynomials. So this guy here, gonna factor this, and I hope it's going to include the binomials of the other two fractions so that when I multiply by it, it can be my least common denominator. I'll cancel all of my fractions, and then we will be in good company. So guess what? That's true. I'm gonna actually leave enough space this time. All right, so we've got 2 over x plus 4 plus 2x minus 1 over, this is going to factor as x plus 4x minus 2. Ha! Would you look at that? Those are exactly the binomials we needed. All right, so I'm going to multiply this side by x plus 4, x minus 2. I'm going to multiply this side, making sure that's going to get distributed. X plus 4, x minus 2. All right, so that's going to get canceled. That whole thing's going to get canceled. All right, and so we'll have 2 times x minus 2 plus 2x minus 1. And that's going to be equal to x plus 4 because this x minus 2 and x minus 2 will cancel. All right, time to start cleaning up. We're going to distribute. We have like terms that we need to combine. And then we can use some inverse operations to find our solution. All right, we got our nice variables on both sides here. We're going to subtract x from both sides. We got 4x minus 5 equals, oh my goodness, look at me. I subtracted x and I left it as 4x. Mercy me. All right. Now, of course, once I click the eraser, the squirrel erase works. All right, so here we go. I've got this 4x, or 3x minus 5 equals 4. We're going to add 5 to both sides, but 3x equals 9, or x is 3. And again, check with your calculator because like I said, this, at least this time, it's not a fraction. It's just 3, right? But you would have to take this 3, right? And you have to plug it in here, and here, and here, and here, and here, and you might as well just check it in your calculator to see if it works. All right, thanks for taking the time out of your day to solve some rational equations with me. I hope that this was helpful. If so, go ahead and leave a comment or like this video and let me know. Love you. Bye.